How you doing? I'm James Hardy. I'm a sophomore mechanical engineer, and we're working on our Physics 2 project.
I'm Kyle Thomas. I'm a sophomore mechanical engineer.
Darius, I'm a junior electrical engineering major.
And today we're going to find the equivalent capacitance of this capacitor network, and then we're going to be finding the charge on capacitor 1, then the charge on capacitor 4. Start it off.
Alright, so first we're going to find the equivalent capacitance of the capacitor. First value of C1 equals 7.41. C2 equals 1.52. C3 equals 13.9. And C4 equals 9.53. For the voltage, it's 13.7 for the voltage. So on the values, we want to get 7.41, 1.52, 13.9, 9.53, and for the voltage, 13.7. And since C3 and C4 is in the series, we're going to get 1 over C3, 4 equals 1 over C3 plus 1 over C4. And that's going to equal to C3, C4 over C3 plus C4. And since C1 and C2 are in parallel with it, we're going to get C equals C1 plus C2 plus the series equation. C3, C4 over C3 plus C4. Alright, so now we're going to plug in the values. C1 equals 7.41 plus C2, which is 1.52, plus C3 times C4, which is C3 equals 13.9 times C4, which is 9.53, over C3, which is 13.9, plus C4, which is 9.53. Total out to 14.688 microfarad.
That's the equivalent capacitance?
Yeah.
Okay, cool. And this is the work that we did. If you couldn't see it before, this is how you find the equivalent capacitance. This is the work for it. Cool. And now I will try to find the charge on this capacitor, capacitor number 1. That's to the left. And the equation that we have for charge is Q equals CV. So this is the equation that we're using. Q equals CV, and Q is charge, which is measured in microcoulombs or coulombs. Capacitance, which is measured in farads and microfarads. And V is voltage, which is measured in volts. So this is microfarads, 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 microfarads. So we have so charge is equal to 7.41 microfarads, because that is the capacitor that we are measuring the charge in. 0.41. And since it's in microfarads, we have to multiply by 10 to the negative 6, because micro, the thing for micro is negative 6. Times the volts, which is 13.7 volts. And then you put that in the calculator and you should get a point 1.17. But this is in coulombs, so we have to convert it to microcoulombs. So it would equal 101.57 microcoulombs. That is what your answer would be for the capacitor to the left, capacitor 1.
Okay, so I'm here to find the charge on the 9.83 microfarads capacitor. And to do that, I'm going to do C3 and C4, and they're in series. So I'm going to find both of them, and then I'm going to find the inverse of that answer. And you can also write it like C3, C4 over C3 plus C4. That's equal to 13.9 over, and then you add them together at the bottom, 13.9 plus 9.83. And when you put all that into the calculator, you get 5.75 microfarads. Okay, and then next I'll plug this into my equation, which is Q equals to C times V, which is charge equal to capacitance times voltage, and that is and that voltage comes from right here, and that's given in the problem, and your final answer is 78.8. microcoulombs.
So basically what we did for this problem is number 1, which we found the equivalent capacitance for C1, C2, C3, and C4. And in order to find the capacitance for C1 and C2, we just added them together because they're in parallel. In order to find the capacitance for C3 and C4, we have to use this equation because they're in series. And number 2, we found a charge on the on C1, which is the one towards the left, and it was 7.41 microfarads. We had to use C1 times V, and that gave us our charge. And yeah, on number 3, what we had to do was we had to take the capacitance for C3 and C4, the series. We had to multiply that times the volts, which was 13.7 volts, and that's how we got our answers for those.